I am Dr. Mohammad Rafi, Associate Professor, Department of Cyber Security at Institute of Aeronautical Engineering. Today I want to discuss about server process crashes in a boundary conditions. Server process crashes. Generally, failure. Whenever the server is the crashes, the server or the failures will be arise. That failure now we can call it as a crash failure in a server. This crash failure in server generally which occurs when a system or a application stop working abort and without warning, generally often resulting in the loss of the unsaved data or even permanent data losses. In many cases, server crash failures is caused by a software bug or hardware malfunctions. But it can also be triggered by the human error or malicious attack. That means now by this malicious attack or human other errors with these other things, it will be triggered into the system. With that now, the server or the process will be crashes. A crash failure is a kind of failure where the system abrupt stop working. It is one of the most serious type of server failure that can occur in a system, server side system. It is almost like a node in a system that was working correctly but now has stopped responding complete and become unresponsive. So the solution to dealing with this other kind of other failure could be a simple, very simple, as just restarting the node. Causes of the server crash other failure are: server crash failures can be caused by a wide range of the factors which including the bugs in the software, hardware failure, power outages and network connectivity issues. Some of the most common causes of a crash failure which includes memory errors. When a system run out of the memory or experiences memory corruptions, it can cause the system to crash. Resource contention. Here, these are all the common causes for crash failure at server. Resource contention. If multiple processes or applications are competing for the same system resources such as CPU time or network bandwidth, it can cause the system to become unstable and crash. Software bugs. Software bugs, that means bugs in the software code, can causes the system to crash or behave the unpredictable. Hardware failure. Hardware failure or malfunctioning the hardware components such as hard drives, power supply, memory modules can cause the system failure. Network connectivity issues. Due to the network the connectivity issues also, server or the process can be crashed. If the system release on the network or the connections to the functions and issues with the network can cause the systems to fail or crash or they become the unresponsive of the server. External dependencies. Here, any breakdowns in the external service of the server or the components on which a system depends can cause a crashes in a server. And concurrency issues. Concurrency, the parallel execution. In a server executed the parallelly with multiple clients. Whenever the server executing parallelly with multiple clients, generally the concurrency, the issues will be arised when threads or the process interfaces with one another in a multi-threaded or multi-processing system, which incorrect the synchronization or raise the conditions can causes the failures in a server side, in a server system. Input validation failures. User uses inputs. Whenever user uses the inputs that have not been sufficient or incorrectly validated, may behave the unexpectedly, and which will be resulting in a crashes. Whenever the inputs are not sufficient, the inputs are incorrect. It is a not the correct, not validated or not verified correctly. So in this situation, input the validation and the verification, the failures will be arise at server side. Security vulnerabilities. Security vulnerabilities generally due to the network or the weakness and system, these security vulnerabilities are arising. Crashing can be purposeful caused by the attackers using exploiting the security the flaws. That is a weakness of the system. Now these are the security vulnerabilities will be arised. So it can be attackers. Attackers can be attacked. Whenever this issue is arise, the attackers over the internet, so the attackers can be attacked to the server whenever the security vulnerabilities are arise at the server side. And implement a fault tolerant design. That means fault tolerant design aim is to prevent or minimizing the impact of the system failure. For example, implementing automatic fail over the mechanisms or RAID storage that can help to preventing the data loss in a server in case of the hardware failure in server. Perform the regular maintenance. If you are not maintained regularly, generally these type of the issues will be raised. That means regular system maintenance, such as updating software. Suppose the software is expires. Now you have to update time to time. That is updating software is a maintenance, and the replacement components, hardware components replacement. So which can help and preventing the crash failures that is caused by the outdated or vulnerable other components. With these things now, so these are the performance regular maintenance for improving the performance of the server or the process. With this one also the crashes will be arise. Testing. Testings are unit testing, integration testing, and stress testing are the examples of the rigorous the testings that can be used to find and fix the problems. So that could causes the crashes at server side. Security measures. Security, the use of the security best practices now to stop the malicious actors from taking the advantages of the vulnerabilities that could cause the crashes at server side. User input validations. The user input validations are to avoid the unexpected behavior that may cause the crashes through verify and clean the user inputs. That is a user input validation. Crash the failures can have the very serious consequences for a system availability, reliability, and data integrity. By understanding the common other causes of crash failure, so and implementing the prevention strategies, that is, system designers and administrators can ensure that so their systems are very reliable and available as the possible for crashes. Here, error boundaries are a powerful tool in a React for handling the errors while performing the process. So, and the preventing them from the crashing the entire the application, and imagine an error boundary. So, like a safety net surrounding which specific components. When an error occurs within the wrapped the components, the error boundary catches it and prevents it from the propagation the further. Instead of this the crashes, server the crashes, the error boundary display a custom feedback. That is a custom feedback with help of this custom feedback user interface now. So the error boundaries can be displayed. Which the type of errors now we can identify with help of the user feedback of the user interface. Often the informing to the user and providing potential solutions at the server side. So the crash, the failures can have the serious the consequence for the system availability, reliability, and data integrity. So by understanding the common causes of crash and the failures and implementing the preventions strategies, system designers and administrators can help ensuring their systems are reliable and available as possible. This is about the server process crashes. Here, use error boundaries when you want to prevent the crashes in your app. It will be caused by the unexpected errors in a certain part of user interface. It helps to your the applications whatever it is running smoothly on a server side. Every if something goes wrong, here the steps to implementing the error the boundaries in React are, so we are going to discuss the steps to install and creating reacting the apps. Step 1, creating the application. So with the help of the below command, that command is now by using this command npx create a React application app my app. The app name is my app. Now with this the command, now we can creating the my app application with the help of this command. So after creating your any reactive or the projects, any your other projects or the folder, so that is my app or the project. So move it to using the following the command, that is the cd my app command. By using the cd my app command, now we can move it to this is the project from one location to the other location. Here is now we can see step 3. So after setting up the React environments on your the mission, so we are able to start by creating the application. So that is we have to store it as app.js file, Java server side. So here and the directory and the name after the components in which we will write our required the function. This is a project as a structure, my app project. Here the structure src node the modules and the public src components and app.jsc. Now so creating, now we are creating app.jsc file and the directory named after the components, and here so package log.json, the package json, the number of the commands is the given. So this is the project structure which indicates the project structure. Here is now updating the dependencies in a package .js file. That means whatever the dependencies or exist in this package now, we can updating the number of other versions are the updated. Ensure that your package .jsn the file include these necessary other dependencies. So with these the dependencies, generally the server the crashes will be the happened here. These are all the here the server. Now it is the implementation for error boundaries for server process the crashes. So that's why whenever for avoiding the server process the crashes, now these number of the versions are updating the number of versions in the package. That is a package dot json json. So here is now we are updating this React DON 18.2.0 version at React script 5.0.1 here, web vitals 2.1.4. Now by updating these the dependencies to the version, now we can avoid the server process crashes. And the limitations of using the error boundaries in at server process crashes. Let us discuss the limitations of using the error boundaries in React. In simple term, error boundaries in React can only catches the errors that occurs during the rendering phase. Lifecycle methods or constructor of the component. Here is they cannot catch the errors in event handler, asynchronous code. By using the asynchronous code, now we are correct handling the errors during the server side rendering. So these are all the limitations and each error boundary can only catches error with its own subtree. So if an error occurs in a component outside the boundary subtree, it won't be catched by the boundary conditions. You need to place the multiple error boundary strategies throughout your the applications. It will be covered all the potential error the sources. If an error occurs in a component, so that causes to unmount the error boundary level should be very higher. So in the hierarchy, won't catch the errors. Whenever the error boundary levels are very high, no, which can't able to catch the errors. So now, when it is catching the errors, the error boundary level should be so medium or low. Easily it is catches the errors. This means here the error boundary cannot recover from unmounting errors. Here is error boundaries are implemented using class components and the compound and component did catch lifecycle method. Error boundaries are implemented using class components and component did catch lifecycle method. If you are using the functional components with hooks extensively, implementing error boundaries might require the refactoring the components to class components. Each error boundaries are not meant to be replacing regular validation and error handling within the component, whatever the components you are using. They are more about the graceful handling unexpected errors that slip through your verification and validation of the logic at server side rather than replacing it all other together. And the placing error boundaries too high in the component the tree that can be potentially impacted the performance and error that can be catch for every render cycle within that the subtrees. It is essential to strike a balance between the error coverage and the performance overhead. You see the concepts of the error boundaries in React Redux Linux operating system. Here, error the boundaries in React Redux are components that catches the errors within their child component tree. Within the child component tree means within the client's component the tree. So these client component the trees now which are preventing the entire the application from crashes or failure, server crashes or server failure. They display the feedback UI when an errors occurs, which improving the user the experiences by handling the errors at a low level and medium level errors. Error boundaries can be implemented around the connected components, at the server side, helping the isolating and managing the errors with a specific part of its the applications. That is my app or the applications like. Here, error boundaries in a React Redux are error handling components, and error boundary is a React component that catches the error occurring in its child component during the rendering life cycle method or constructors. So this prevents the app crashes. And error boundaries, whatever the error boundaries is there, these error boundaries preventing the entire the React the application at a server side from the crashes due to the error handling in a specific component or subtree or the client subtrees while handling the errors. Instead of that, now we can displaying the feedback user interface. So by displaying the feedback interface, also now we can identify the errors at the interface level, allowing the rest of the applications to maintaining the functions. Here the boundary definitions. Boundary definition, that means here error boundary definition. Now error boundary definitions are defined using the special lifecycle methods. So that is a like the component did catch which intercept the errors through by the component in its subtree. Feedback UI. Feedback UI, when an error occurs within an error boundary child component, the boundary renders the feedback UI, which is specified by the developer. The user interface can be simply sending the error messages, or the more which is specified the more the complex the component usage of the at the server side. Nested the boundaries at the server side, error boundaries can be nested. That means errors within the error. Nested means here errors, nested boundaries now which specify the errors arise within the errors. That can be nested errors, can be nested with each others. Now providing the granular control over the error handling, level of the granularity at the handling at different levels of the component hierarchies, low level, medium level and high level. And here is the error boundaries in React Redux which now help, which is preventing the application crashes. Whatever the applications are utilizing at the server other side, here the crashes arise here happened. Crashes happened at the applications can be prevented by catching the errors at low level and medium level and high level, and displaying the feedback of the user the interface. UI feedback can be displayed and identifying the errors in which level errors are arised while the processing, low level processing, high level processing and medium level the processing. Here now identifying the feedback, error feedback, displaying the error feedback based on the processing levels. Boundary value analysis, the technique can be used for identifying the errors at boundary levels. The core of boundary value analysis is used to testing the boundary values of both valid and incorrect partitions. Here it searches for the input values that are the more likely to include the errors when they are close to the borders. Every partition has a maximum value and a lowest value which serves as the partitioning the boundary values. One of the most popular the case the designing technique for block box testing is a boundary value analysis. Because the input values closest to the boundary have a large like of inaccuracy. It is used to test the boundary values. Here is the boundary values. Low level boundary and high level are the boundary. The boundary values now, it is the boundary value or the analysis diagrammatical representation. Here, the advantages of the boundary value analysis in a testing. What are the advantages? The benefits of boundary value analysis are: this method makes it very simple and very quick to discover the flaws. This is a result. This is a result of the higher defect density near borders. Now we only choose the set of test data that is at the border rather than testing with all data sets, whatever the data sets available at the boundary levels. As a result, the total test execution time will be the decreases. Now for checking all the boundary values at the all levels, now the speed will be the decreases. Execution testing speed will be decreases. Boundary value, that means the total testing execution time will be decreases. Execution time now, time complexity, now we can decrease the time complexity. And disadvantages of the boundary values, the analysis in a testing. Here the drawback of boundary value analysis are: this method makes it simpler and quicker to discovering the flows. So this is a result of the higher defect density near the borders at boundary levels. We only choose the set of test data that is at the borders rather than the testing with all the test data sets as a resulting. The total test execution time should be the decreases, and the space complexity should be the increases for testing the all the levels, low level, medium level, high level. The number of the levels of the testing here, we are going to testing all the levels now. Space complexity should be the increase. Equivalence value analysis, the difference between the equivalence value analysis and boundary value analysis. So the input data is split into the partitions of the valid and the incorrect values in these other techniques. Boundary value analysis, in order to find the fault in the input center, we use the technique that involves and identifying the flaws at the input data orders. Here the input to the program, the applications are divided into the groups and predict to behave the similarity in a equivalence value analysis. In a boundary value analysis, boundary values are ones where the variable should be the upper and lower boundaries are present. In equivalence, it enables us to separate a group of test circumstances into a division that ought to be treated equally. The boundaries between the partitions are examined using the boundary value analysis. Here, the amount of test cases will be cut down to a small set of the table test cases by applying the equivalence, the partitioning, which covers all possible outcomes. Due to the reduction in the test cases from the infinity to the finite number, testing time will be the shortened. All level of software testing, including unit, integrations and system testing, can be accommodated by equivalence of the partitioning. Due to the reduction in the test cases from an infinite to a finite number. Testing time will be the short-ended in a boundary analysis. But it is common to refer to the boundary value analysis as the component of stress and negative testing at boundary levels. So what happens if the server crashes? Here, if it is a server, now if it is a crashes, it is a data center. Now all data can be maintained at the data center, and video and financial and gaming number of here the impacted. It will be the impacted. The server is the fail. Now it is internally impacted on a data center and impacted on the videos or financial and gaming and all related areas. So it will be the impacted. Once the server is crashes, there may be the problem with the various other services built into the servers. And because the server serves a large number of other people, that is, which are interconnected to the data center. So that means the data can be the hold here. And the impact will be the wider and the consequences will be the more other serious. So if the server is crashes, video websites, if the server is crashes in a video websites, there is a large scale of inaccessible failures. Online videos cannot be watched in a YouTube. In case the data in the server is lost, and the original videos and the animations of authors cannot be restored, it will be the disaster. That means the financial system. In a financial system, with the tens of millions of the transactions, that requires the rock solid server banking system. After all, it is affected everyone. The capital is exchanging, and loss in calculable. That is the best example is the banking system. Any financial the systems. If the server is a failure, the losses will arise. And competitive games. The online players of the popular the competitive games may exceed tens of millions of levels. That means here, now asking what is the experience of tens of millions of people being disconnected at the same time. So there will be definitely not to be the good answer. Here is, why does the server crashes? The contradiction between the fast growing number of users and the server, the performance cannot grow at the same time. So the server will be the crashes. Here next, the exhausting of the resources, that means the CPU, memory, hard disk, which is caused by the large number of services the request. Mass the visits in a short period of time have impacted on the performance of the server. Unexpected the reasons, due to unexpected reasons, the server will be the crashes. Here, the references, the server in a server process, the crashes network programming here, the references are. So these are all the references. So Richard Steven, the book is a Unix network the programming, volume 1, the Pearson Education, 3rd edition, 2018, with the native main and money Subramaniam network the management, the principles and practices, and it's a really the publications, 1st edition 2001. So these are all the text the books and reference books, web references. So this is about the server crashes. Server process crashes.
Like, share and subscribe. Hit the bell icon for more updates.